material after this. 8.1 sequences and summation notation, also called sigma notation. Sequences and summation notation, also called sigma notation. So what is a sequence? It's basically a function between natural integers. So like, for example, a1, comma, a2, comma, a3, comma, dot, 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 comma, an, dot, dot, dot. This is an infinite sequence of numbers. a1 being the first term of the sequence, this a2 the second, so this is first term, this is the third term, this is an R and this is a D term. This is called the general term. Okay, so first let's just, let me just say that sequences can be given to us in two different ways. I'm just trying to find that one to tell you the page we're going to work on. Last page for this semester is page 752. This is it. Okay, a sequence can be given to us in two different ways. Given a sub n, which is the general term. And there is a second way. It's called the recursive formula. So we can be given a sequence by given to us the general term or a recursive formula. Let's look at an example from each, and then we'll talk about sigma or the summation notation. So let's say number 10 on page 752, of course, we're given a sub n equals 3n over n plus 5. These are all n's, not m's, n's. Okay. We're asked to find the first four terms. So how do I determine the first term? I replace n by 1. Good. How do I determine the second term? I replace n by 2. That's it. So 3 times 1 is 3 divided by 6, which is 1/2. 3 times 2 is 6 divided by 7. 3 times 3 is 9 divided by 8. And 4 times 3 is 12 divided by 9, and I will simplify it into 4/3. And this, what was given to us, was the general term, a sub n, and we were asked to find the first four terms. Now the other possibility is when we are given a recursive formula. Okay, let's say problem 16. In problem 16, we are given a1, which is 2. That's given to us. And then we are given the a sub n, but not directly, but equals 5 times a n sub 1 times a n minus 1. And this is for n greater than or equal to 2. Obviously, because we are given a1. The same question, we are asked to find the first four terms of the sequence. So a1 is already given to us. a2, a3, and a4. So let's try to understand what the recursive formula means. I am given the general term, but it depends on the term before it. So if this is 10, this will be 10 minus 1, which is 9. So the 10th term is 5 times the ninth term. the 8th term is 5 times the 7th term, and so on and so forth. So if n is 2, 2 minus 1 is 1. So A2 is 5 times A1. I have A1. I have the first term. So then A2 will be 5 times 2, which is 10. Can anyone dictate A3? So when this is 3, this is 2, and I have A2 to be 10. This is 2, A2. So 5 times A2, which is 50. What about A4?
Well, 5 times 5, 50. 250.
Is that clear? Okay, so this says that A9 equals 5 times A8, or A10 equals 5 times A9. This is n. This is 1 before n. N minus 1. So if I'm asked to find A2, I have to write 5 multiplied by A1. A1 is 2. And I get 10. Now A3 is 5 multiplied by A2, which is 10. So it's 5 times 10, which is 50. A4, if this is 4, then this is 3. 5 times A3, which is 50. And I get 250.
So A5
will be 5 times 250, correct. Because that's what this says. Any term of the sequence is 5 multiplied by the previous one, n minus 1. If this were n minus 2, it would have been the one before. Yes?
Maybe a general thing to say is A(n) basically equals x. If in that like equation, it's like a variable. It just means everything. And then x minus 1, I guess.
If you want, yes. But that's if this is 9, then this is 8.
Yeah.
So A9 will be 5 times the previous term. Is that better?
Will the first term be given?
The first term was given to us. Yes. But then you can't determine it. If you don't have the first term, you cannot find the second one because the second one depends on the first one.
Is there a way to find it, or is it
No. No, it has to be given to us. The starting point in a recursive formula, it has to be given to us. Some recursive formulas depend on the first 3 terms. So we can have, you're not going to see it in this class, but that's a possibility. Something like an equals an minus 2 plus an minus 1 plus 3 an minus 3. What does this mean? I have to be given the first 3 terms. I have to be given A1, A2, and A3, because otherwise I will not be able to find A4. So in this case, 3 terms, the first 3 terms are given, and then I can find the rest. So what does this mean? So if this is 10, then this is 9, this is 8, and this is 7. Okay, any questions so far? Okay, let's take a look at what it's called, the factorial notation. Factorial notation. 5 factorial is 5 times 4 times 3 times 2 times 1. 16 factorial will be 16 times 15 times 14 times dot 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 times 3 times 2 times 1. By convention, 1 factorial is 1 as well as 0 factorial is 1. We have never seen something like this before. 2 different things to equal the same number. By convention, this is, okay, so in general, what is n factorial? It's n times n minus 1 times n minus 2 times n minus 3 times dot dot dot, 3 dots times 3 times 2 times 1. Let's simplify a couple, and then I'll show you how to put this in the graphing calculator. For example, 26 on the same page. 20 factorial over 2 factorial times 18 factorial. Okay. So I know it's a silly question, but I'm going to ask you, which of these two numbers is bigger? 20. Right. So here is what I'm going to do, and you will tell me why I'm doing that. 20 multiplied by 19 multiplied by 18 factorial divided by 2, which is 2 times 1, 2 factorial, multiplied by 18 factorial. Why did I stop at 18 factorial and I didn't continue with 18 times 17 times 16 times times 3 times 2 times 1?
Because there's an 18 at the bottom.
Because these two go away. That's it. 1 and 1. And I will also simplify by 2. And the simplified form is 19 times 10.
With like a factorial on the bottom.
18 factorial divided by 18 factorial is 1. 18 factorial divided by 18 factorial is 1. Oh, the 2? 2 factorial is 2 times 1. Any questions? Any questions? Okay, so let's look at one more, and then we'll do it with an example with the graphing calculator. What about 16? This is problem 25. 16 factorial over 2 factorial times 14 factorial. Very similar. What would you do? There is no point in putting this in the graphing calculator. You can, I'll show you in a minute. But I see that 16 or 14 is bigger and not too far away. Which one? So you'll write 16 multiplied by, right, factorial. And 2 factorial is 2, and 14 factorial, and I'll simplify. And I'll simplify again by 2, and I get 8 times 15. With the graphing calculator, please. Very easy. Promise. 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 So which one would you like to check? The first one or the second one? First one? Okay, fine. So let's put 16. Go to math. 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 Scroll to the right to probabilities. And select number 4. And you have 16 factorial. Divided by, in parentheses, please, 2. Go back to math, across to probabilities, select number 4. Multiplied by 16. I'm sorry, 14. Go back to math, across to probabilities, select 4, and close the parentheses. When I hit enter, what should we get?
120.
Yes. Any questions? Any questions? Is this okay? Wendy? Yeah. Now here's one. 27. N plus 2 factorial divided by n factorial. You cannot put this in the graphing calculator. So we need to know how to simplify this. Which of these two is bigger? Exactly, it's n plus 2. How will you break it down? And where will you stop?
N factorial plus 2.
Careful, I have to start with n plus 2. Multiplied by n plus 1. Multiplied by factorial, indeed. That's exactly where I'm going to stop so that I can cancel the denominator. So then I have n plus 2 times n plus 1, and of course I can distribute, and I get n squared plus 3n plus 2. So that's the reason why we need to remember how to simplify these factorials, because you cannot put this in the graphing calculator. Any questions? Any questions? Okay, the last topic, promise, very last one. Okay, so let's say I have 2 plus 2 squared plus 2 cubed plus 2 to the fourth plus 3 dots plus 2 to the nth power. And the question is there a way of writing the sum in a condensed way so that I don't have to list so many terms? And yes, there is a way. And the notation is S standing for sum. But this letter, although very nice letter, it's not good enough for what we're trying to do. So we're going to use a Greek letter that is also S, Greek letter S, but it's much better for what we're trying to do. And it looks like this. So this is the Greek letter S, or sigma. And this is the summation notation. Okay. The summation notation has right here a lower limit, and right here the top has an upper limit. So let's see what changes here. Not the base. The base is 2 in all these numbers, correct? But what changes is the exponent from 1 to 2 to 3 to 4, to n. So we're going to use an index. Normally the index is either lowercase I or lowercase j or lowercase k, doesn't matter, any of these letters. So one more time, if we use I, it goes from 1, and what is the last one? 1, 2, 3, 4, n. So we say the sum from I equals 1 through n. What is the base of all these numbers that does not change? And what is the power? Well, it has to be the index. So instead of writing all this, I'm going to write this notation. What does this mean? When I is 1, I have 2 to the first power. The sum says plus. When I is 2, I have 2 squared. Again, the sum says plus. When I is 3, I have 2 cubed, plus 2 to the fourth, plus ... till the last or the upper limit, n to the n. And I would like us to come up with 52. In 52, we are given 1 over 9 plus 2 over 9 squared plus 3 over 9 cubed plus ... plus n over 9 to the nth power. They're asking us to write the condensed sigma notation, summation notation, whatever you want to say. And use the index you like. You can use I, you can use j, you can use k. Let's use k this time. From k equals to what? From k equals whatever till what? Very good. And from k equals what number? 1. Exactly. And now what do I have in here? An expression that when k is 1, I get the first one. When k is 2, I get the second one. When k is 3, I get the next one. And when k is n, I get this one. What would you say? So the denominator is 9 raised to k. Perfect. What about the numerator? Okay. Very good. Let's check. When k is 1, 1 over 9. Correct. When k is 2, 2 over 9 squared. Correct. When k is 3, 3 over 9 cubed. Correct. When k is n, n over 9 to the n. Correct. Okay. One more. 1 over 3, so this is problem 50. 1 over 3 plus 2 over 4 plus 3 over 5 plus dot, 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 exactly 3 dots, 16 over 16 plus 2. Ready? Where do we start? Whichever index you want. We used I, we used K, let's use J this time. So J goes from 1, 2, 3, 16. From J equals from 1 through? Very good. And what is the generic term? Must be a fraction. Very good. That's it. So when J is 1, 1 over 1 plus 2. When J is 2, 2 over 2 plus 2. When J is 3, 3 over 5. When J is 16, 16 over 16 plus 2. Any questions? Any questions? One last type, promise. 33. The sum from k equals 1 through 5 from k plus 4. Find each indicated sum. I don't know what I have to add. I have to see the terms. How many terms do I have to write? Exactly. When k is 1, 2, 3, 4, and 5. Give me the first one without any calculations for everyone to see. 1 multiplied by 5 plus multiplied by
9.
2 multiplied by
6.
perfect plus 3 multiplied by perfect plus 4 multiplied by
11.
plus 5 multiplied by very good. And now I know what I have to add. 1 times 5 is 5. 2 times 6 is 12. 3 times 7, 21. 32 and 45. Okay, so let's see what I have. 26. If you have this number, don't torture me. Plus 44 and plus 45. So this is 89 and 26. Is it 115? So we determine the sum. Any questions? Let's look at another one. Yes, number 40. From I equals 0 through 4. From -1 raised to I plus 1 over I plus 1 factorial. First of all, how many terms? We're asked the same thing to determine the sum. Last new problem. After that, I'll do what you want me to do. So 0, 1, 2, 3, 4. Yes, only because this one starts at 0.
That started at 1, might be 1.
Correct. So let's write it first to see those 5 terms. -1 to 0 plus 1 is 1 over 0 plus 1, 1 factorial. Plus, when I is 1, -1 raised to the second power over 1 plus 1, 2 factorial, plus. When I is 2, -1 raised to the third power, 2 plus 1, 3 factorial. Plus, when I is 3, -1 raised to the fourth power over 3 plus 1, 4 factorial. Last one. negative 1 to the 5th power over 5 factorial. Okay. Negative 1 to the 1st power is negative 1, and 1 factorial is 1, so the first one is negative 1. Plus, negative 1 squared is positive 1 over 2, because 2 factorial is 2. Negative 1 to the 3rd is negative 1. But how much is 3 factorial? 3 times 2 times 1. Perfect. Plus 1 over 4 factorial. 4 times 3 times 2 times 1. So it's 6 times 4. Very good. And the last one, negative 1 over, of course, 24 times 5. Good. Okay. The least common denominator. $120, 60, 20. What is this? Oh, yes, of course. And then 1. Thank you. So negative 120 plus 60 minus 20 plus 5 and minus 1. So this is 40, negative 80, and then plus 4 over 120. So negative 76 over 120. Or if I simplify by 2, this is 38, right? If I simplify by 2, this is 19 over 30. Any questions? What type of problem you would like to practice now? So we're starting our review. Anything you want. It can be from the handout. It can be. Wendy, any questions?
Matrices.
Yes, very good. So we want to go back to matrices and Gauss-Jordan elimination, Gauss-Jordan method. And this is in 6.1. Yes, the pattern is very simple. 1, 0, 0, 1, 0, 0, 1, 0, 0.
I got that.
Okay.
But like,
Sure. Let's start another problem. Let's say 22. X minus 2y minus z equals 2. 2x minus y plus z equals 4. Negative x plus y minus 2z equals negative 4. Did you think about that, Eric? About that form? Did you think about it? Okay, no problem. Happy Thanksgiving. See you Tuesday. Tuesday we're going to review, and the test will most probably be on Thursday. Okay? Say it again. No, because school is closed. Yeah, so we shut down tomorrow around 2, 3 o'clock, and we don't reopen on Monday. Yeah, so, sure. Everything okay? Oh, I thought you were. Okay, so let's start working on this. Run to the back.
Oh, she has lots and lots and lots of scrap paper. I'm gonna need it.
Plus row 2. So when it's talking about this number here, is it talking about these numbers
Row
the
2.
entire time?
No,
I mean, well,
rows.
like this, but like, is it talking about that? Like row 2 is the sum of whatever this row is equal to? Or is it row 2
No, the whole thing.
plus that?
It's the whole row.
No. I'm trying to get this to 0 right now. That's what I'm doing. So it's this number times this number,
Zero, because it has to be zero.
and then this would be that, and then plus row 2. So I'm guessing it's this. So to bring it to 0, we're just canceling it out.
So it'd be the second and the third.
Yeah.
So
But, no, I'm talking about.
to get that to zero, you have to multiply it. See, now that's a zero.
So I'm talking about the numbers that I interact with. This is the first one. This is the first one I use. And then I mess with this one next. To make it 0 is that number. And then, what is that? Is it this?
I think it's just the placement in row. That's the row we're dealing with.
No. But no. Like,
Oh,
it's this number. It's
Yeah.
this number
Yeah.
times this number.
Yeah.
Plus this number.
Does it work?
Pretty sure that's what it is.
So negative 1 times 1 is 1. Negative 1
Negative 1 and then plus
plus
1.
1. Negative 1 plus 1 is 0. Right?
This entire thing only does this. Or does
No, it only does that.
this one here. But then like what do I do? Like this row this thing right here interact with this entire row.
Actually, it doesn't interact with the entire row because it only changes the first two numbers. It's just the row we're looking at.
Right.
So we're looking at.
This one, oh, okay.
You don't get it either.
I get it now. I understand.
Alright, now explain it.
So that stays the same. That becomes 0 because blah, that, and then
Sorry about
there's
that.
So it's that.
Ready?
I don't understand.
Ready?
Yes, please.
Very good. So, the augmented matrix would have 1, 2, negative 1, negative 1, negative 2, negative 1, 1, negative 1, 1, negative 2, and the free terms, correct?
Yes.
Good. Let's start that. One, 2, negative 1, negative 2, negative 1, 1, negative 1, 1, negative 2, 2, 4, negative 4. Correct? This is already done. I'm happy. I will be using row 1. Correct? I need to multiply 1 by something to eliminate this. What would that be?
-2,
Perfect. I need to multiply 1 by something to eliminate this.
1.
Exactly. Very good. Ready? Which row do I copy? Because I'm using it, it cannot change. Correct. Ready? Together. 1 times negative 2 plus 2.
0.
Perfect. Negative 2 times negative 2.
Negative 4.
Careful.
Oh,
Ne-
positive 4.
Positive 4 minus 1.
3.
Very good. Negative 1 times negative 2
It's 2.
plus 1.
3.
Awesome. 2 times negative 2
Negative 4.
plus 4.
8. Right? 4 plus 4.
2 times negative 2
Is negative
Negative
Oh,
8.
0.
1 times 1 minus 1. Negative 2 times 1
Negative 2.
plus 1.
Negative 1.
Negative 1 times 1.
It's negative 1.
Negative 1 minus 2.
Negative 3.
2 times 1
2.
minus 4.
Negative 2.
What do I want next?
The second row, we need a 1.
But I cannot just make 1. I have to divide the entire row.
Can't we swap it?
You can. Or divide everything by 3.
Oh.
And if you have, if it turns out to be a fraction, I will rather swap. But if it's not a fraction, same thing. You will get the same answer. 1, negative 2, negative 1, 2. 0, 1, 1, 0. 0, negative 1, negative 3, negative 2.
I got lost.
We divided both sides here by 3.
No, I'm talking about to get the third row for the blue one. Not
Here,
the down, the one with the circle part, that part.
this one.
Yeah, how did you do
Okay.
that again?
So 1 times 1 minus 1 is 0. Negative 2 times 1 is
Okay.
negative 2 plus 1 is
Yeah,
negative
I
1.
see.
So negative 1 minus 2 is negative 3, and 2 minus 4 is negative 2.
Okay.
Better?
Yes.
Very good. So now I need to get the corresponding zeros. Which row I have to use now? To get the corresponding zeros.
2.
Correct. I have to use row 2 by multiply by something and add it to row 1. Okay, so I want to eliminate negative 2. What do I need to use?
1. No. 2.
Good. I need to eliminate negative 1. What do I use?
1.
Perfect. Which row do I copy because it will not change?
2.
Perfect. 0, 1, 1, 0. And of course 1 and 0, otherwise I'm going backwards. So 1 times 2 minus 2.
0.
1 times 2
2.
minus 1. 0 times 2
0.
plus 2. 1 times 1 minus 1.
Negative. No, 0.
1 times 1 minus 3.
Negative
3.
2.
0 times 1
0.
minus 2.
Negative 2.
Where am I now? What do I need to do next? Yes, so what do I do? One zero one two 0 1 1 0 0 0 1 1. Which row do I have to use now? I used row 1, I used row 2, there is no other way. Yes. What? Negative 1 in both cases, very good. Which row do I copy? Very good. So let's do this together, last step. 1 times negative 1 plus 1.
0.
1 times negative 1 plus 2.
What was it? Negative
1 times negative 1 plus 2.
negative 2.
1 times negative 1 is negative 1, plus 2 is 1. 1 times negative 1 plus 1 must be 0. That's 1 times negative 1 is negative 1 plus 0, negative 1. So careful when you multiply and add. So the solution appears to be,
1, negative 1, 1.
I don't know, to go back and check 1, negative 1, 1. 1, negative 1, 1, 1, negative 1, 1, 1, negative 1, 1. 1 plus 2 is 3, minus 1 is 2. 2 plus 1 is 3, plus 1 is 4. Negative 1 minus 1 is negative 2, minus 2 is negative 4. So now I don't need anyone to say anything because I know this is the correct solution. And there is no other.